We have no announcements today, anything, so we can just get started. Yesterday we talked about, last 2 days we talked about reference angles, calculations of reference angles. You had the odds on page 13 to go through any questions you have on any of the problems. Yeah, I give you the odds. The reason why I give you the odds so you can check your answers. Okay, so hopefully you did check your answers. If you don't know by now, in math books, the odd answers are in the back of the book. If you don't know that by now, back of the book I call Bob. So Bob is your friend, Bob is your pal, Bob is your buddy. What about Bob? Questions you have on any of the problems you had on page 13? Once again, draw a picture, draw a picture, draw a picture. Anytime you have any of these problems, get a picture down. Get a picture down so you have a visual, because trying to visualize in your brain is somewhat difficult at times, especially when you start getting multiple steps within the math problem you have to deal with. It gives you one last thing that you have to visualize through your brain in regards to the math work, because as we go through this, problems will become a little bit more complicated as we go through, convoluted with just things that you will have to know. Because everything we're going to utilize, we're going to continue to build on. Because today what we're going to talk about is we're going to talk about trig ratios. Okay, trigonometric ratios. The one thing that you had that's pretty much a carryover from your geometry class. We started talking about trig ratios. Before we get into trig ratios, we're going to talk about our good old buddy Pythagoras. Okay, one other thing that you talked about in your other class is the Pythagorean theorem, and we're going to talk about our good old buddy Pythagoras, because Pythagoras is here to keep us from harm's way as we go through our trigonometric problems. Pythagoras was born in 580 BC. And died in 500 BC, so he lived 80 years old. Back in the BC era, to live 80 years old, that's pretty good. He was a philosopher and a mathematician, was born in the Aegean island of Samoa. As a young man, he traveled to Egypt, where he saw elementary principles of geometry used in building the pyramids and in surveying. Pythagoras would later develop further these same mathematical principles. When Pythagoras began teaching, he and his more advanced students formed a close-knit group called the Pythagorean Brotherhood. The Pythagoreans were bound by oath not to reveal the teachings or secrets of the school. Because it is difficult to separate the discoveries of Pythagoras himself from one of those of his students, he is generally credited with the discovery of the Pythagorean theorem, which can be used to find the length of one side of a right triangle when the length of the other two sides are known. The Pythagoreans considered numbers to be the guiding principle of their philosophical system. They found a close connection between numbers in the math world and the order, proportion, and the harmony of the universe. Their studies laid the foundation of all later developments in geometry. So you walking into this class and taking this class, this trig class, and starting to learn these ideas, you are now an honorary member of the Pythagorean Brotherhood. Welcome to the Brotherhood. We used to get a needle out and prick our thumbs and get the little blood going there, and we put them in the middle, and we used to start doing that, but bloodborne pathogens start taking that out, so we don't do that anymore. But you should be feeling pretty large today, walking out of this classroom, because you are a member of the Pythagorean Brotherhood. Feeling pretty good about that. Feel good. Well, our good old buddy Pythagoras, there's another picture of him. He keeps us from harm's way as we do a Pythagorean theorem idea. Okay, when you're dealing with a Pythagorean theorem, you must have a right triangle. Well, how do we know a triangle is a right triangle? How do we know a triangle is a right triangle? Yeah, it has a right angle, has a 90-degree angle. A triangle with a 90-degree angle. With a right angle. That is a right triangle. Well, part of that right triangle, we have three sides of any triangle. Okay, we have the legs. Anybody remember what the legs are of a right triangle? The legs of the right triangle. We have two of them. Yeah, two sides that form the right angle. Okay, the two sides that form the right angle. Those are the legs. So you have two of them. And then you have the hypotenuse, which is opposite the side opposite the right angle. So you have the legs that form the right angle, and then the hypotenuse is opposite to the right angle. So what we have here is we have a triangle. And when we have the Pythagorean theorem, hopefully we remember, if we square the lengths of the sides that are the legs, we square them and add them together, we'll add up to the square of the third side. So what I would like you to do is I would like you to apply. We have length of A is 12, length of C is 13. What I would like you to do is write a Pythagorean equation and solve for little b. And once again, Pythagoras, watching over you. Keeps you from harm's way as you venture through the Pythagorean theorem. We don't want you to get any injuries. Watching over you. What's the length of the third side? Little b. Jade, what equation did you write? Okay, throw numbers in. 12 squared plus b squared is equal to 13 squared. Once again, you're going to have to apply your Pythagorean theorem. I know if you remember your Pythagorean triples, you'll be able to come up with that, but you're going to have things that aren't Pythagorean triples. We can subtract our 12 squared from both sides. So we have b squared is equal to 160/90 minus 144, or value 25. Jade, what do you get for b then? There's a value of 5. And this is a 5, 12, 13 triangle for a Pythagorean triple. Okay, all the numbers are nice whole numbers. Well, what we're going to be dealing with, the main portion of today, is the idea of trigonometric ratios. When we're talking about trigonometric ratios, they are ratios of the sides of a right triangle. Ratios of the sides of a right triangle. What I will so kindly refer to them is as trig ratios, because trigonometrics is like 5 or 8 syllables. That's way too many for an old man to spit out every time they have to say it. So I will say trig ratios. The first trig ratio is the sine of an angle. The sine of an angle. It is abbreviated SIN, but that is still pronounced the sine of the angle. This is not the sin of the angle. The angle did nothing wrong. So you don't say it's the sin of the angle. It's the sine. When we go down the road there, we're not driving down Milst, or we don't turn down Schultz. We say it's street, Mill Street, Schultz Street, Church Street. Sine of the angle theta is defined to us as the length of the leg opposite the angle theta over the length of the hypotenuse. The length of the leg opposite. It was chilly this morning, wasn't it? That was cold. I don't live very far, so when I get in my car, it's cold to begin with. It doesn't get a chance to warm up by the time I get here. I don't have the nice fancy steering wheel warmers for my hands or a seat warmer for my butt. They didn't invent that back in 2005 when I bought my truck. It's cold. Length of the leg opposite the angle theta over the length of the hypotenuse. Opposite over hypotenuse. We have the cosine. It's the length of the leg adjacent. And the key word there is leg. It's length of the leg adjacent to the angle theta over the length of the hypotenuse. Because the hypotenuse will also be adjacent to the angle theta, but this is the length of the leg adjacent. So it's the one that forms the right angle that's adjacent to the angle theta over the length of the hypotenuse. So we get sine is O, cosine is It's like watching fireworks. And the tangent. And these are all things that you should have learned back in geometry. Length of the leg opposite the angle theta over length of the leg adjacent the angle theta. Length of the leg opposite the angle theta over length of the leg adjacent the angle theta. Oh, wow. Now, there's different ways of learning these. I used to be an I used to be a firework person. Just learn fireworks, left to right, on your calculator, sine, cosine, tangent, but as I've gone along, we have our trigonometric guardian, SOHCAHTOA. Used to be the Indian, but we can't say the Indians anymore, so should have worn my guardian shirt today. My bad, I missed out on that one. Our trigonometric guardian, SOHCAHTOA. Let's see, other things I've learned as I've gone through. Some old horse caught another horse taking oats away. Some old horse caught another horse taking oats away. Whatever works for you. What I would suggest, though, whenever you get a quiz, a worksheet, anything, you write that at the top of your page. So you can refer to that as you go through the problem. So you don't have to sit there and remember, okay, now what was sine, what was cosine? You don't have to remember that. You can just refer back up to, okay, I got sine, that's opposite over hypotenuse. I have cosine, that's adjacent over hypotenuse. Tangent opposite over adjacent. New things for you will be our reciprocal functions. The cosecant, the secant, and the tangent. When we reciprocate, all we're doing is we're taking a fraction and we're flipping it over. Okay, reciprocal functions. When we have a cosecant, this is 1 over the sine of theta. It's the reciprocal to sine. So it's hope. It's a reciprocal to sine. The secant is a reciprocal to cosine. Ha. And then the tangent, or the cotangent, is a reciprocal to tangent. The cos do not go with each other. C goes with S, S goes with C. The cosecant goes with the sine, the secant goes with the cosine. C goes with S, S goes with C. The cos do not match up. And tangent and cotangent, they match with each other. So you can still refer to this, but when I have cosecant, okay, cosecant is reciprocal to sine, I got hypotenuse over opposite. With right triangles, there's two special types of right triangles that you'll be responsible for. The first one is a 30-60 right triangle. And once again, this is not Dr. Clark's class where you have the flip charts that you can refer back to. You're going to have to know these. Okay? You have to know them, where there's not going to be any diagrams on the side boards here. Okay? You will have to learn these. But you'll get enough practice with them. You'll get enough practice with them that hopefully it will get embedded into your brain. When you're talking about a 30-60 right triangle, that means one angle is 30 degrees, one angle is 60 degrees, one angle is a right or a 90-degree angle. The hypotenuse is always going to be twice the length of the shortest leg. The hypotenuse will be twice the length of the shortest leg. So one angle is 30 degrees, one angle is 60 degrees. My two legs form the right angle. Outside of the reason why, because it looks it. How do we know which triangle or what side of a triangle is the shortest side of the triangle? I know we have because it looks it, but we also know the ACT disclaimer, the pictures drawn may not be drawn to scale. So you can't go with because it looks it. You guys are right now. Let me see if anybody else knows. Why? They've just been through this, so. Why do we know this has to be the shortest leg? Mathematically. Why do we know that has to be the shortest leg, mathematically? There's a property of geometry in triangles that makes there's that a reason why. Nobody knows. The doorbell rings. Nobody's home. Let's take a look at the angles. Okay, this is going to be the short side because it looks it, but take a look at our angles. We have 30, we have 60, we have 90. Refers back to the idea of the angles. All right, Grayson, tell us. Smallest angle. Here's our smallest angle. The side opposite our smallest angle has to be the smallest side because it's not going to open up as much. So this is the smallest angle. This has to be the shortest side. So we're going to give this a value of 1. Why? Because 1's easy to work with. The hypotenuse will be twice that length. So if this is 1, that means the hypotenuse will be 2. So if we use our good old buddy Pythagoras, if we use our good old buddy Pythagoras to find our third side, I tell you, he's going to keep you from your harm's way while you're using Pythagorean theorem. We have 1 squared plus x squared is equal to 2 squared. So we have 1 plus x squared is equal to 4. Subtract your 1. X squared is equal to 3. X equals square root of 3. So our third side is going to be square root of 3. I want exact values. I do not want decimals. So when going through the problems, you're going to have to leave things in exact values because we're going to have things you can click and clack into your calculator and say, oh, there's my answer. Nice little long decimal there. No, I want exact values there. So I want the square root of 3. Now you might sit there and say, well, square root of 3, isn't that going to be the biggest number that we have there? Well, if I take the square root of 3, I get a value that's approximately equal to 1.732, which is between 1 and 2. So what you're going to have to remember is across from the 30 is a 1, hypotenuse is 2, across from the 60 is the square root of 3. We have a 45-45 right triangle, which is an isosceles right triangle. The length of the legs of the right triangle are congruent. And if I take a look, I'm opposite at 45-degree angles for both of these. Okay, so my sides opposite, since my angles are equal, my sides opposite are going to be equal. So with a 45-45, I'm going to use 1 and 1 again. Why? Because those are the easiest numbers to work with. Then using our good old buddy Pythagoras, 1 squared plus 1 squared is equal to the hypotenuse squared. So we have 1 plus 1, which is 2, equals h squared. So h is going to equal the square root of 2. So for a 45, 45 right triangle, we have 1, 1 square root of 2 is our 3 values. Now the connection to what we just dealt with respect to drawing angles and determining a reference angle. The sine of theta will equal the sine of theta reference. The cosine of theta will equal the cosine of theta reference. The tangent of theta equals tangent of theta reference. So if I find the reference angle, the sine of the angle theta will equal the sine of that reference angle. So if we take a look at the sine of 120. I want to calculate the sine of 120 degrees. Once again, we start dealing with pictures. You first get your picture of a 120 degree angle. With 120 degree angles, what quadrant does that put us into, Ash? 120 degrees. I'm sorry, what? Third? I'm going to start here. If I go 120 degrees, Ash, if I go 120 degrees, it's going to rotate me all the way down to here. Second quadrant. There we go. So it's going to rotate me into the second quadrant. So here's my 120 degrees. Our reference angle is determined by the terminal site and the x-axis. What is the measure of our reference angle? 60 degrees. So we have 60 degrees here. Now what we're going to do is we're going to complete our triangle by drawing a line down to the x-axis. Well, what we have just created is a right triangle here because I draw a vertical with my horizontal. I have 60 degrees here. I have 30 degrees here. I've created a 30-60 right triangle. So the 30-60 right triangle, we have 3 values we need to put in. A 1, a 2, and a square root of 3. So go ahead and throw in your 1, your 2, your square root of 3. 1 goes across from what? 2 goes across from what? And square root of 3 goes across from what? Once again, you're going to get enough practice with these that you'll hopefully will have second nature to be putting the 1, the 2, the radical 3 in. Our 1 goes across from the 30. Our 2 goes on the hypotenuse. And square root of 3 goes across from the 60. Now, the one thing that we have to check with. Suppose I put a point right up here. I go to the left and I go upwards. What would be the ordered pair of this point right here? Ethan, what would be the ordered pair of this point? Farnsworth? -1 and radical 3. -1 square root of 3. Because I'm going to the left 1, then I go up square root of 3. That's how I deal with ordered pairs. Well, if I went to the left 1, if I take a look at this triangle, this side that goes to my left has to become a -1 because of my ordered pair right here. I go to the left, then I go up. So I have a -1 here. So if I take a look at the sine of 120 degrees, now I look at my trigonometric guardian. Okay, I'm looking at the sine. My sine of my angle then would have to be what, Ella? Okay, opposite of our hypotenuse. What's opposite my angle here? Square root of 3. What's hypotenuse? 2. So we have square root of 3 over 2. Because my angle here, the sine of my angle 120 has to equal the sine of my reference angle, which is 60 degrees. But I have to make sure I get my negatives in here. What would be, just for giggles here, what would be the cosine of 120 degrees? Well, cosine is adjacent of our hypotenuse. Maddie, what would be the cosine of 120? What's adjacent to my angle here? What's my adjacent leg? Adjacent means right beside it. Yeah, that's my hypotenuse. -1. So we have -1 over the hypotenuse, which would be 2. So we have -1 tooth there. We take a look at the tangent. Change that to 225. Change it to 225. Draw your 225-degree angle. Draw your vertical line up to your x-axis. Put in your reference angle. What's the measure of your reference angle? What values go in with that reference angle to that triangle? Check for any negatives. Do I go to the left? Do I go downwards? If I go to the left, that side's going to be a negative. If I go downwards, that side will be negative. So once you throw in your values, we have should have a reference angle of 45 degrees in there. So we have values from our 45, 45 right triangle. So you throw in your 1, your square root of 2. Check for any negatives that go left or downwards. And then tangent, what's tangent defined to us as? As you get into more upper level mathematics, it is not just a quick one-step type of solution. There's multiple steps to the solution here. You need to get a picture down. You need to get a reference angle down. You need to be able to find lengths of the sides of the triangles there. You have to check for positive negatives. Then once you get that picture down, then you look at your trig function and apply your trig function. 225, Jane Schleibel. What quadrant do we end up in? Third quadrant. What's our reference angle? 45 degrees. So we complete our triangle. So we have 45 and we have 45 here. 45, 45, we have 1 square root of 2. Do we have to make any of these negative? Sarah Jo, do we have to make any of these negative?
Yeah.
Which ones? Which values will be negative up here? I have a 1 and I have a 1 and I have a square root of 2. Which values will be negative?
Square root of 2.
Do I go left and down? Or your hypotenuse will always be positive. Okay, your hypotenuse will always be positive. Do I go to left with any legs and do I go downwards with any legs? I'm here. Do I have to go to the left or downwards with any of my legs and my triangles? Well, just tell me which values will be negative. Which values of my triangles will be negative here? If I start here, what would be this ordered pair right here? If I ask me this, or tell me this, if I would ask you the ordered pair here, what would be the measurements of this ordered pair here? The coordinates. -1 and what? So I'm going to go -1 to my left. Ordered pairs. My x value, my y value. That's an ordered pair. That's what the first chapter was about. I'm doing an ordered pair. What would be my ordered pair here? That's your y value. What would be my y value of this ordered pair? How do I determine a y value? How do I determine a y value of this ordered pair? -1 took me to here, came across to here. I'm okay with that. How do I find this second part here? Yeah, it's 1. I go to the left and I go downwards. But since I went downwards, what do I have to put with the 1? Negative. So this is -1, -1. So both of these have to be negative. So tangents defined to us as what, Sarah? Whitmer? Tangents defined to us as what?
Adjacent. Opposite.
Opposite over adjacent. What's opposite? What's adjacent here? -1 over -1. Which is a value of +1. Terminal side. Terminal side of an angle contains a point ordered pair 4, -3. Draw a picture, draw a picture, draw a picture. So the terminal side, if I look at my terminal side, goes through this point right there, the ordered pair 4, -3. Spins all the way around. I want to find the sine, cosine, tangent of these values. Well, once again, I can complete my triangle. Here's my reference angle, which I don't know. And I don't really care because the reference angle just gives me the lengths of sides of triangles, guides me to the lengths of sides of the triangles. Well, if I take a look at the sides of these triangles, what does this top side have to be? Skylar, what's this top side have to be? But what if I take a look? I have the ordered pair here, 4, -3. What's this top side have to be? 6. How'd you get 6? Nah, I'm just moving along here. 4. That's a value of 4. What's the length of this side have to be, Sydney? -3. So I have 4 here and I have -3 here. Well, what I have is I have a right triangle. So we have our good old buddy Pythagoras. Yeah. We'll bring him down here. There we go. Now we can utilize our good old buddy Pythagoras to find the third side, the hypotenuse. So we have 4 squared plus a -3 squared. Now watch your -3 squared. -3 squared is not -9. It tells us to take -3 times -3, which is +9. Or if I know my Pythagorean triples, one side is 3, another side is 4. What's the third side? Pythagorean triples. One's 3, one's 4. Anybody remember what the third side is? What's my Pythagorean triple? Now, if I don't remember, then I run it through. 16 plus 9 equals 8 squared. So we have 16 plus 9, which is 25, is equal to 8 squared. So h has to equal what, Isaac? 5. So we have a 3, 4, 5 triangle. So if I look at my 3, 4, 5 triangle, the sine of theta is equal to the sine of, once again, our reference angle. The cosine of theta is equal to the cosine of our reference angle. Our tangent of theta is equal to the tangent of our reference angle. So Lucas, what's the sine of our angle or our reference angle? What's sine defined to us as? What's opposite my reference angle? -3 over 5. Cosine of theta is equal to the cosine of our reference angle. What's our cosine going to be? Melanie? What's cosine defined to us as? What's cosine defined to us as? What's cosine defined to us as? Adjacent over hypotenuse. What's adjacent to this angle? Adjacent, right beside it. I can't hear you. 4 over hypotenuse, which is 5. And tangent is opposite over adjacent. So we have -3 over 4. Homework. It's Tuesday's assignment, page 19, 3 to 42, multiples of 3. Page 19, 3 to 42, multiples of 3. The next 2 days, we'll be just going over more and more of these problems. Okay? So page 19, 3 to 42 multiples of 3. Any questions? Adios. Have a great day. Feel large today. Feel pretty good today. I don't remember Pythagorean brotherhoods.